Chapter 4 of Real World Psychology is called Sensation and Perception. So this chapter is all about the five senses and how our senses help us perceive things in our world. So the definition of sensation is our sensor cells in our sense organs that receive stimuli. So basically that just means how does our brain help our senses convert information to us? Our perception is how does our brain assign meaning to the things that our senses gave us? So your sensations is taking in the information through your five senses: seeing, smelling, touching, tasting, hearing. Your perception is you're able to make sense of whatever you have sensed because your brain assigns meaning to it. There are two automatic processes that naturally happen in our brain that are a way of combining our sensory receptors with our thinking receptors and our level of perception. They are bottom-up and top-down processing. So bottom-up processing has to do with starting at the sensory level, so starting with your five senses and working its way up to your brain for interpretation. Okay, so when something happens, when you smell something, you take in that smell, and then the information goes up to your brain and you can recognize that's the smell of bacon or whatever. Top-down processing begins with the cognitive processing in your brain based on your prior knowledge and expectations to recognition of those individual features. Here's a good example of top-down processing. Reading. Okay, when you're first learning to read, bottom-up processing occurs, right? So you realize that there are lines, you realize what the squiggly letters mean when it comes to making up words, and eventually you are able to read that second bullet point even though there are misspellings because of top-down processing. You're able to use your prior knowledge. All you need is the first and last letter of every word to be able to read it correctly because your brain is going to use top-down processing to do the rest. Let's start talking about some of our sensations. So when it comes to our five senses, there's a link between our physical characteristics of how we experience something and the psychological terms associated with it. That is the field of psychophysics. Psychophysics studies the link between the physical characteristics of something or a stimuli and the psychological experiences of them. Absolute threshold and different threshold are two terms related to psychophysics. Our absolute threshold is the smallest amount of something that we can reliably detect. Like how much of something do I needs to be there for me to notice it's there. The difference threshold, also sometimes called Weber's law, is what difference needs to take place in order for me to notice that there has been a change. That's known as the just noticeable difference. Here is table 4.2 from your textbook. It tells us, based on our five senses, some of the thresholds that may exist for your senses. For example, you might smell one drop of perfume that's spread throughout a 6-room apartment. If your olfactory senses are activated, like what is your threshold for being able to smell the perfume? Is it just one drop? Because it could be one drop for me it might be 4 drops for you because our absolute threshold is different for being able to smell something. Now, the difference threshold has to do with what change needs to occur for me to detect or notice something. So, if for me it only takes 1 drop of perfume, but for you it takes 4, then those extra 3 drops of perfume that it took to make a difference in you noticing it would be the difference threshold. When it comes to our senses, after we are constantly exposed to something, so after you've been constantly exposed to a stimulus, your ability to sense that stimulus fades or disappears over time. So if you've been in a restaurant for a while, or if you've ever been to somebody's house and it has a specific smell, after a while you won't notice that smell. That oftentimes happens in the homes of people who smoke. After a while, they don't notice the smell of smoke that may exist in their home, whereas somebody who comes in new is going to say, "What is that smell?" Or "It smells like smoke." The gate control theory of pain is a theory that exists when it comes to our sense of um, touch, or even our experiences of pain. So your spinal cord has a neurological gate. Now, obviously, it's not a real gate. It's just think of it as a gate that is able to block pain signals or send pain signals to the brain. So this gate kind of controls whether or not your brain recognizes something as pain. So your spinal cord's job is to communicate with the brain. So for whenever you stub your toe or something like that, if your gate in your spinal cord is open, you're going to feel the pain of stubbing your toe. If the gate in your spinal cord is closed, you will not feel the pain of stubbing your toe. But what is your natural reaction to that? Your natural reaction is to rub the area where you've experienced pain, because your brain you're not thinking about it, but you are naturally trying to close that gate. Phantom limb pain is a really sort of debilitating condition that oftentimes exists in people who have experienced war, or for some reason had a limb amputated. What tends to occur is sometimes, even though the limb has been lost, the nerves that exist in the stump of the missing limb tends to feel like sometimes reorganize and makes the person feel like that they still have their limb, which can be very devastating. I had a client once who was in a wheelchair and had double amputations on both of his legs. And sometimes he would fall out of his wheelchair because his stump was activated and phantom limb pain occurred, and he thought that he had his legs and could walk. And obviously, he was not able to, but he would try to get out of his chair. So just having to re-experience and go through that again can be very devastating. Oops, a little too far. Okay, now let's talk about our vision. So when we see, it is because light waves hit our eyes. So there are some light sensitive areas in our eyes called rods and cones. Rods that are responsible for our ability to see black and white, and cones that are responsible for our ability to see color. Those exist in our eyes' retina. The visual cortex is actually located at the back of the brain, and obviously for helping us see forward, in an area of the brain known as the occipital lobe. And you'll see all of the lobes of the brain in the chapter and later in the PowerPoint. When it comes to our ability to see, there are millions of different color hues that help us perceive color. There are two theories on our ability to see color. There's the trichromatic theory, which says that we see colors in terms of, three major colors: the red, the blue, and the green. And then the opponent process theory, which says that we recognize color because of its opposites, like black and white and things of that nature. Color deficient vision has to do with color blindness. Many people might experience red-green deficiency or blue-yellow deficiency. If you look at figure 4.1, you should be able to see a number 3 there. Here's a good image to kind of show you what a color after image, how that's illustrated. So if you look at the flag of the United States and you stare at it for about 30 seconds, so maybe even 20 seconds, I'm gonna let you stare for a few moments. What should happen is if you stare at that dot, that white dot that's in the center, and then look at a blank white wall, you should notice something. You should notice that you see the opposite color for each of the colors that are there. When it comes to our hearing, that's known as our audition. That has to do with sound waves and hair follicles that exist in our ears' cochlea. Our auditory cortex, our ability to actually hear, is located in our temporal lobe. And that picture that you see gives you an idea of what a sensory receptor cell looks like with the hair follicles adjoining it. Here are some of the major areas of the human ear, the cochlea being the most important. That's where those hair follicles are that help us hear the best. We know that there are some disorders of hearing, such as conduction hearing loss and sensorineural hearing loss as well. These two conditions may require some hearing aids and surgery, especially for conduction hearing loss. If there's nerve deafness, that could be because of loud noises. It could be based on biology. It's one of those things that I wonder about with how we now have like the AirPods and things like that. I wonder if, putting those in our ears very close to those hair follicles are going to cause any nerve deafness. Our sense of smell is known as olfaction. Olfaction is the only sense that's not processed in just the temporal lobe, whereas everything else is processed through the thalamus. The sense of olfaction is actually processed, and those receptor cells are in the olfactory epithelium. Having your sense of smell is important for being able to also recognize taste. So your sense of olfaction is a chemical sense, which, as I said before, it works along with your sense of taste. The conversion of odorants in the olfactory bulb is how your sense of smell works. And the information you take in through transduction is sent to the brain so that you can make meaning. Another important sense is gustation, or your sense of taste, and that has to do with molecules that exist on your tongue, molecules for all of the different taste areas. There's an example of what a taste sensory receptor cell looks like. The whole purpose of us having a sense of taste is not so that we can just enjoy the food, but also so that we can avoid poisonous foods or foods that would not be helpful to us for survival. Taste buds are distributed all over your tongue, and they're all in different places. Here are the 5 major distinct tastes: taste, sweet, sour, salty, bitter, and umami, which is considered savory. All of our taste preferences develop at a very early age, and they can vary by culture. That's why different cultures eat different foods. The sense of touch is sort of the last sense we need to talk about. It has to do with detecting pressure, temperature, and pain. And our sense of touch is mostly concentrated in our hands and in our feet because, in our face and in our hands, because that's where we spend a lot of time touching things. Now, the vestibular sense is us having a sense of where our body is and our body orientation. So, what I'd like for you to do right now, I want you to test your vestibular sense. If you'll go ahead and just stand up where you are and stand on, just one foot. I'm sure because of your vestibular sense, you can recognize where your body is and how your body is oriented, and you can do that with no problem. Now, keep standing because I want you to also look at kinesthesis, which is the recognition of movement and balance and body position and body weight distribution. So I want you to try the same thing of standing on one foot, but this time I want you to close your eyes and stand on one foot. It's a lot harder to do, isn't it? That's because with kinesthesis, you have to be able to recognize your body position, to balance yourself, to notice where you are. And when we take away your sense of sight, you are not able to recognize your body orientation. Now, that's everything we need to talk about regarding sensation. Now let's talk some about perception. We perceive things based on how our brain takes in the information. So perception is the process of selecting, organizing, and interpreting the senses that come into our world. We have something called an illusion, which is a false or misleading perception that can be shared by others in the same environment. For example, the Muller-Lyon illusion, if you look at both of these lines, which one appears longer? Most people are going to say the one on the right appears longer, when in reality, this is an illusion. This is something that appears accurate that is incorrect. They are actually the same size. When it comes to our perceptions, we have to look at various factors to know how we perceive things. When we select, we choose where we want to direct our attention. Selective attention has to do with filtering out information and only attending to the things that we view as important. So we have selective attention when you are able to focus and do your job even though people around you are talking. Feature detectors have to do with neurons that exist and only respond to certain sensory information. These are specialized areas that are only going to make a response to certain sensory information. This is happening inside your brain. Habituation is another form of selection, which is your brain's tendency to ignore environmental factors that remain constant. So perhaps it could be the ticking of a clock in a room. After a while, you're going to ignore that thing because it's always there. So if you've ever noticed yourself sort of zoning and not listening when somebody's speaking to you, that is probably because of habituation, because your brain is actively attempting to ignore whatever stimulus that's around you, and you know when you no longer want to hear it. The cocktail party phenomenon is a person's ability to focus on listening to a single talker, even though that there might be a mixture of conversations going on. So if you're at a party and you're talking to your friends, but you suddenly hear your name, then you're probably going to focus on that conversation where you heard your name rather than the conversation you're engaging in. Because we all have the ability to listen to a single talker, even though there are many people talking amongst us, if we want to hear that conversation. This is a form of selective attention. When it comes to our perceptions, we tend to organize things in a certain way. Here are 5 different ways of organizing things in our mind. So you can organize objects such as figure ground, proximity, how close things are or how grouped they are to each other. Continuity is when we tend to see objects in patterns that are grouped together. Closure, even though we see the triangle, we see the square, we see the circle, because of closure, our brain will form those closures and make that a triangle and a square and a circle, even though they aren't complete. And then similarity, which has to do with similar objects being grouped together, and we can perceive that. So we can perceive the number 5 because those dots are all greener than the others. Depth perception has to do with our ability to perceive a 3-dimensional space and judge distance and height and the width of objects. One experiment related to depth perception is the visual cliff experiment, which has been performed with babies, even though babies are appear to be at the edge of a cliff. When the floor shows that there's glass there and it looks the same as everything else, they tend to continue on. In order to perceive depth, we use binocular and monocular cues. Binocular cues is when you use both of your eyes to perceive something. Your monocular cues occur when you only use one eye. If you use binocular depth perception, then retinal disparity occurs when your eyes are separating and falling on different images so that you can perceive the image. Convergence occurs when the closer the object is, the more your eyes converge or turn inward to be able to see it. When we interpret things, the last sort of idea listed in this chapter is about ESP, extrasensory perception. It's one of those sort of, pseudo-psychologies. It's that psychic perceptual ability with like telepathy, and it has to do with whether or not a person believes that they have a sense that goes beyond the senses that naturally exist. Some people believe in ESP, other people do not. But research has shown us that one of the reasons, or 2 of the reasons many people believe in extrasensory perception is because it's something they're interested in, and they're sort of motivated by thinking that this exists. That's everything you need to know about sensation and perception.